Hi, everybody. I just want to start by extending my thanks to Alison and Esther, as well as colleagues in the National Centre for Sport and Exercise Medicine and the School of Sport, Exercise and Health Sciences for the invitation to give this public lecture this evening, which, as Alison says, is essentially about strength training for middle and long distance runners. I do appreciate it's a nice, warm summer's evening, so I think most of you would probably prefer to be outside, maybe with friends or family, enjoying the summer evening. So thanks very much for attending tonight. I'm also very aware for runners and any running fans that have joined this lecture that the Monaco Diamond League meeting is starting in about an hour and a half on the BBC. So I'll try to do my best not to overrun and encroach on some live athletics. The aim of this session is threefold. I'm aware that we've got some scientists and academics who have joined this talk. There's definitely a lot of runners and coaches, and there's also some strength and conditioning coaches and students. But I'm going to kick off with a little bit of science around the underpinning physiology of endurance running and a bit of a theoretical basis for why strength training exercises might be beneficial for endurance runners. I'm also going to discuss some of the evidence around whether strength training might offset the risk of injury in runners, which I think is probably a topic which a lot of you will be interested in, particularly if you run a lot. And I'm going to integrate, as part of my discussion, some recommendations concerning the prescription of appropriate strength and conditioning activities for runners, which is certainly the more applied aspects of the presentation. So as much as I like strength training and encouraging athletes to lift weights and do plyometrics and so on, we can't get away from the fact that endurance running has a largely physiological basis. So it's mainly limited by our physiology. And this is quite nicely summarized in what's termed the classical model of endurance running performance that you can see here on this slide. So in the top left-hand corner, we've got VO2 max, or maximal oxygen uptake, which represents the highest amount of oxygen that I can take from the atmosphere, get into the body, transport from my lungs towards my working muscles, and then the working muscles use that oxygen effectively in order to resynthesize energy. On the right-hand side, I've got percentage of VO2 max at LT, which stands for lactic threshold, which is essentially known as my fractional utilization. So this represents the proportion of my VO2 max that I can access for a given distance or duration. So when we combine these two factors together, I essentially get a performance VO2, or amount of oxygen I've got available to fuel performance over a given distance or duration. And there's a third important factor, which you can see on the right-hand side, known as running economy, which essentially represents the efficiency of the conversion of this metabolic energy that we get from VO2 max and fractional utilization into mechanical energy. And that allows us to maintain a certain speed for a given performance of running. This model has been validated across a variety of different studies. You can see on the right-hand side here, the top studies for 10-mile running performance. A scaled version of VO2 max and running economy was used to validate it for middle distance running performance in the paper by Steve Ingham. And then a little bit more recently in the paper that you can see in the bottom right-hand corner, we validated this model for middle distance post-pubertal adolescent runners, showing that 85% of inter-individual variability in performance could be explained with just these three factors alone. Quite interestingly, if we look at different race distances across middle distance and long distance, the contribution that we get from these different aerobic factors seems to change. So they're certainly all important for middle distance performance, but we know that we also get quite a big contribution from anaerobic factors, such as maximal sprint speed and anaerobic capacity. But what I'm keenest to impress upon you on this slide is that as the race distance increases, the contribution that we get from running economy also increases. So although it's important that we've got good running economy if we're a middle distance runner, it becomes increasingly important if we're targeting longer distances, such as the half marathon and the marathon. So VO2 max and fractional utilization are predominantly limited by cardiovascular and metabolic sort of physiological factors. But quite interestingly for me, as a strength and conditioning practitioner, we know that running economy is influenced by a variety of different systems and factors beyond just cardiorespiratory and metabolic characteristics. So you can see here in the middle of the slide that running economy is also influenced by some biomechanical factors. So a study that was done here in 2017 by Professor Jonathan Folland showed that there was a number of kinematic or technical factors related to the way in which runners run that influence our running economy. So therefore, technique seems to play some role in having good running economy. But then crucially, we've got this set of neuromuscular factors in the middle related to the way in which I'm innovating different muscle fibers, the amount of range of movement that I can exhibit at different joints, and then the way in which I'm using my stretch shortening cycle or plyometric type qualities are also heavily influential in how good my running economy is. One factor that wasn't on that previous schematic relates to my balance of strength or running technique between right and left sides. And we carried out a piece of work quite recently, again, in postpubertal adolescent distance runners, to have a look whether interlimb strength asymmetry was a determinant of running economy. So we didn't really find very much for performance and running economy in the male athletes, but for the female runners, when we looked at their essentially gluteal strength, so hip abduction strength that you can see here on the x-axis on the screen, we essentially showed that the runners that had larger strength asymmetry, so a bigger imbalance between their right and left sides in their glute strength, had worse running economy. So worse running economy on this graph would be represented by being higher up the y-axis on the left-hand side. I guess what's important to note here is that we had at least 3 runners that you can see here on the right-hand side of the scatter plot that had very, very high levels of strength asymmetry. So this probably explains why we saw a relationship. What we typically see when we test runners in the gym or in the lab is that strength asymmetry only seems to be about 10-12% at very most. So we've got this excessive amount of strength asymmetry in these 3 runners, which seems to pull the relationship across that way. But if we're testing this with runners in the gym or in a field-based setting, I'd be a little bit cautious. There'd be a bit of a red flag for me if I saw a runner that was more than 10% in terms of their strength asymmetry around the hip in particular. So again, it does seem to be an important determinant of running economy that we might want to look at as part of our testing battery and address as part of a training intervention if indeed strength asymmetry is very high. So in the late 90s, based on, I guess, this newer understanding of the determinants of running economy, this kind of classical model of endurance running that I showed on the very first slide that includes VO2 max, fractional utilization, and running economy was redrawn very slightly to include these neuromuscular capabilities that we know partly underpin running economy, but are also important for these anaerobic factors, which are key for middle distance running performance, such as maximal sprint speed and anaerobic capacity. So it kind of begged the question in the late 90s, well, does improving these neuromuscular capabilities via strength training and maybe some speed work improve maximal speed running economy and therefore our middle and long distance running performance? So the first study that I did as part of my PhD, which was 6 or 7 years ago now, was actually a systematic review to try to address this question. Okay, let's have a look at all of the literature that's evaluated whether strength training is beneficial to middle and long distance runners. So to do this, I applied the criteria that you can see here on the slide, that we wanted to find studies that had only used trained distance runners, and we defined that as they had to have been engaged with the sport and only distance running as their sport for at least 6 months. We only wanted to include randomized control trials, which essentially means that the study took a group of runners and then split them into a control group that carried on their normal running training, and then a group that added some form of strength training exercise. That strength training exercise is needed to last at least a month. And we wanted to include studies that had used heavy resistance training, which were defined as being 12 repetitions or less, explosive strength training, which is moving light to moderate loads as quickly as possible, and plyometric training, which is things like jumping, hopping, bounding for distance. And then the study needed to have at least one of the physiological measures that are previously defined, so VO2 max, fractional utilization, or running economy, or some sort of performance measure, and that's usually a time trial or a maximal speed type test. So the table you can see here on this slide actually summarizes about 11,000 words. So I'm kind of condensing down quite a lot of information just into a single table here. But the pattern that we saw in the results across 26 studies and 469 runners was that typically performance improves as a result of doing a 6 to 14 week strength training intervention. Running economy seems to decrease, and a decrease in running economy is a good thing because it essentially means that we're using less energy or less oxygen to run at a submaximal intensity. And then unsurprisingly, based on what I mentioned on a previous slide, VO2 max, speed at VO2 max, and speed at various different points on a blood lactate profile didn't seem to change at all. The main reason being that those factors don't seem to be heavily influenced by neuromuscular capabilities. And then there was a few studies that had measured maximal sprint speed, one study that had measured anaerobic capacity, and they're typically shown improvements in those anaerobic qualities as a result of doing the strength training intervention. There was a similar systematic review and meta-analysis that had been conducted around the same time that we published this review, and that showed a similar improvement in running economy, about of the order of average of 4% across the studies that they included. You can see that shown on the right-hand side of this slide. Just digging a little deeper into some of the nuances associated with that 11,000 words and the information that we included in this review, that there seemed to be a benefit across various different subpopulations of runners. So if we go back sort of 10, 15 years and look at some of the early studies in this area and some of the review papers that were coming out, there was this suggestion that strength training was the sort of training activity that only well-trained and elite runners should be engaging with, when essentially they've maxed out their VO2 max and they're kind of looking for very small improvements in performance. But we didn't really find that in our review because there was quite a few studies that had used recreational, moderately trained individuals and shown improvements of a similar magnitude to those in well-trained and elite runners. We've obviously got quite a dearth of literature specifically in female athletes across the sports science literature, and this particular area is no exception. But there are one or two studies that have only used females. There's a number of studies that have used mixed sex cohorts of runners, and they've typically found improvements that are similar in male and female runners. So there seems to be fairly similar improvements across both of the sexes. There's been one study that's been done in young runners, plus there's one that I'm going to present in the next couple of slides, and a couple of that have been done in over 40s, so master or more aging runners, again showing improvements of about 4 to 6% in running economy. Often get the question, well, is strength training something that I should just be doing in pre-season or in the build up to a big half marathon or marathon target? And it seems that there's a relationship between the magnitude of change that we get in running economy and the duration of a strength training intervention. This was shown in the meta-analysis that I mentioned before, and you can see it visually represented on the right-hand side, that the longer the training intervention, the larger the improvement in running economy that we see. Typically, the longest training duration that we see in these studies is kind of 12 to 14 weeks. There's been one study that took the participants for a full year, but we could do with longer duration studies just to assess whether this change in running economy plateaus off at a certain point with the same type of strength training. We observed that no matter what type of strength training that runners do, whether it's heavy resistance, explosive strength work, or plyometric training, the improvement in running economy seems to be fairly similar across those three very general strength training modalities. So we put the suggestion forward that probably varying the type of strength training that a runner's doing would be best, particularly over a long period of time of up to a year. Some of the studies had compared heavy resistance training against lighter loads, and there's also been papers that weren't part of our review that have done the same thing. And it seems that a kind of circuit training, muscular endurance type approach offers less improvement to running economy compared to lifting heavy. That might sound a little bit counterintuitive because obviously if we're trying to improve endurance, it would make logical sense to train muscular endurance. But because of the physiological basis that I've explained at the start of this presentation, lighter to moderate loads don't seem to offer the neuromuscular system as good a stimulus to gain adaptations and therefore improve things like maximal speed and running economy compared to lifting very heavy. So therefore lifting at 12 repetitions or less seems to be more beneficial than lifting very light. Often a question that I get from coaches and runners that haven't engaged very much with, well, particularly heavy resistance training in particular, is this association with going to the gym, lifting weights, and gaining muscle mass, which is obviously going to be disadvantageous to performance with runners. So there was 24 out of the 26 studies that had actually attempted to measure body composition on some level, and 22 of those 24 studies actually showed no change in body composition compared to the control group that were only running. So from a kind of purely evidence-based perspective, this fear of gaining body mass seems to be unfounded. There's probably a few reasons for this, and reasons why that runners don't really gain very much muscle mass as a result of engaging in resistance training. Firstly, a lot of the studies that have been published have used fairly low volumes of work. So they've done 2, maybe 3 sessions a week. And within those sessions, there's been a total of between about 7 and 12 sets across different muscle groups and joints, which actually represents a sort of low to moderate amount of volume. And we know the biggest driver of a change in muscle size or a hypertrophy type response is the volume of work, or the total tension that we put through a muscle within a session. So if that's fairly low to moderate, we seem to get away without increasing muscle mass too much. Typically, a lot of the studies have used a training to non-repetition failure approach. So that's stopping 1, 2, maybe 3 repetitions short of repetition failure on an individual set. And so therefore, again, this lowers the amount of volume that typically runners are performing within a session. And so therefore, we're less likely to get a hypertrophy response. And there's also been quite a lot of research that's had a look at cellular signaling responses to both endurance training and strength training, and then programs where we try to combine those two things, like in the ones that I've presented. And with very high volumes of running training in particular, we seem to see a cellular signaling interference response, particularly if the running and the strength training is part of the same session, or there's a very short recovery between those 2 bouts of exercise. This seems to be further exacerbated when participants are in an energy deficient state, which often distance runners are, particularly if they perform very high volume training sessions. So as a result of this interference, it might sort of provide a blunting or compromised response to the protein synthesis that's occurring within a muscle, and so therefore reduce the extent to which runners are gaining lean body mass as a result of engaging with resistance training. Again, another question that I often get from coaches, which is obviously a very good one: if you want to be good at running, you need to do a lot of running. It's just the law of specificity. And therefore, if we're going to the gym, would time be better spent performing running? So adding a running session or doing a little bit more as part of running sessions that are already in the program. And it's a fair criticism of the work that's been done in the past, because 21 of 24 studies in our systematic review actually added strength training to the program of runners, whereas the control group just carried on their normal running. So visually, it kind of looks something like this, which if we go off a kind of rough 80-20 rule of thumb in terms of training intensity distribution in a runner's program, around about 80% of total training time is slow, easy recovery type running. About 20% of total training time is tempo, interval training, and high intensity type training sessions. If we add strength training to that program, it kind of looks like we're chunking on an additional amount of physical work on top. So therefore, to some extent, it's a bit of an unfair comparison, because the control group is doing less physical work compared to the strength training group. This was one thing that we tried to address in a study that we did, and this was part of my PhD, again in post-pubertal adolescent distance runners. So we took a group of 25, 13 female and 12 male post-pubertal adolescent distance runners. We put them through a fairly standard physiology test, which included an estimate of body composition, a VO2 max test, measures of running economy, and a blood lactate profile. On a different day, they did some strength and speed tests, which included maximal strength in a quarter squat position, an explosive squat jump, and also a maximal speed test over 20 meters from a rolling start. We then split them into 2 groups. One group was the intervention group, and they were asked to reduce the amount of running that they were doing by reducing the volume of easy and steady running that they had as part of their program, which allowed us to accommodate 2 additional strength and conditioning sessions as part of their program each week. And then the control group were asked to just carry on their normal running. How this looked visually is shown on the right-hand side of this slide, in that you can see the low intensity proportion of running that contributed to the overall physical work that the strength training group was doing came down to just about 41%, whereas the control group carried on their normal amount of low intensity running. The amount of high intensity work they were doing was pretty much the same between the groups, but there was quite a large proportion, therefore, of the overall training week, which was strength training in the intervention group. They adopted this program for 10 weeks, and then they came back to the lab and did the physiology test and the strength and speed tests. I'm just going to digress very slightly just to expand a little bit, go back a slide, on what the actual intervention group did and what the 2 strength and conditioning sessions looked like, which I guess sort of pragmatically and from a fairly applied perspective, kind of represented what I often use as a strength and conditioning coach with runners that I've worked with in the past. So the 2 sessions lasted about an hour in total and were constructed in the way that you can see here on this slide. That the initial 10 minutes, which was essentially just a warm-up, kind of acted as movement preparation, where we worked on some neuromuscular control, we worked on some mobility, particularly in functional running type positions, and we did some targeted activation work, particularly for muscles like the gluteals. There was then a 5 to 10 minute portion of plyometrics and running drills, and that also included some high-speed sprinting towards the end of the program. They then did about 20 minutes of resistance training, and that was a combination of some explosive work, some bilateral exercises, and then some work just on one leg, plus some upper body work. And then the final 10 to 15 minutes of the session was what I would term tissue conditioning. So this is more targeted strength work to particularly tissues that are vulnerable to injury in endurance runners. And you can see the types of muscle groups and joints in that final cell on the right-hand side. Just to have a quick break from my voice, I've just got a few videos which are particularly designed for those of you that are perhaps new to strength training or are considering incorporating some strength training as part of your running program. So here you can see some examples of resistance training exercises and the type of work that we do. The runners that are using these exercises are some of them have reached Olympic finals, all the way through to quite recreational runners and 14, 15-year-olds. So we've got Romanian deadlift and deadlift from the ground, as well as various different variations of squatting exercises. We've got the hip thrust exercise, which is obviously specifically targeting gluteals and hamstrings. And then on to unilateral or single leg exercises. Often dead leg step up is a staple exercise as part of my program. And then more loaded versions of step ups. And I typically characterize my single leg exercises into, I guess, 2 main movement streams: stepping exercises and lunging exercises. So split squats, Bulgarian or rear foot elevated split squats that you can see here on the slide, and then into different variations of lunge patterns would form part of that movement stream. And then some examples of more explosive resistance training, which just to redefine, is moving light to moderate loads as fast as possible. So different variations of medicine ball throwing, bilateral and unilateral box jumps, sled pushes, a very light, more explosive version of a step up, which can also be done from deeper positions, such as a reverse lunge into an explosive box step up. And I guess this exercise represents something that's more complex, double box step up. And then we use a lot of Olympic weightlifting derivatives. So various different hang positions for both clean and snatch. And then building up to doing pulls from the ground before we go into the full lift. And then some quick examples of some plyometrics, which again are mainly jumping, hopping, bounding type movements. So these initial ones are very low intensity in nature, so are suitable for runners that are new to plyometrics. They're definitely good for young athletes. And we used a lot in the program that we worked with in the adolescents. What we're mainly looking for here across, whether it's low, moderate or high intensity plyometrics, is to be very reactive and responsive off the ground. So when we're getting an athlete to bounce back off the surface, we're looking for a minimal ground contact time and then trying to maximize the height that we're getting from the hop or the jump. This is moving more into, well, for these athletes, more moderate intensity plyometrics. For your Olympic level high jumper, these would still be very low intensity. And then this is much more high intensity. And that athlete was an Olympic finalist in 2016. And then some examples of some unilateral exercises. So hops and steps. And to work on motor control, particularly trying to force the knee to move across the body in different directions, but to stabilize with ankle, knee, hip alignment. We'll often use zigzag and lateral movements to try to challenge the athlete in those directions. And also working across different surfaces, which obviously changes the stiffness and compliance of what we're asking the musculotendinous unit to do. And obviously bounding, yeah, that's quite a competent athlete, but it represents one of the most high intensity exercises. So we were talking about a study here, and I'm just going to kind of bring us back to the results of this study now. The most important measure or dependent variable that we had was running economy, and we saw a small improvement of a similar order to what previous studies had shown, of about 3.5% in the strength training group. The ES stands for effect size of 0.45, which is about a moderate type change compared to the control group that just carried on their normal running. I don't want to get too bogged down in all of the statistics here because it's probably beyond the scope of this session. I think most studies would usually use a repeated measures analysis of variance to analyze this type of data. And if we apply that statistical test to the data that we had, we would have got a statistically significant result. We actually used an analysis of covariance, which just accounts for differences between the two groups at baseline and is actually a more robust statistical test to use in this circumstance. And we actually didn't see a statistically significant change when we applied the analysis of covariance. So we weren't able to definitively say that there was a definite improvement in running economy compared to the control group in this particular case. We also use something termed magnitude-based inferences, which the academics on the call will know has been quite heavily criticised over the last 3 years. So we got some praise as part of the review process in our paper, but it's now a statistical technique which isn't used very much. I guess the only thing that I would say about the way in which we use the magnitude-based inference in order to get a possibly beneficial effect in terms of our conclusion is usually the threshold that's used for magnitude-based inferences is the smallest worthwhile change, whereas we use a minimal detectable change at a 95% confidence, which you can see labeled on this figure here. And that was taken from the reliability study that preceded this particular intervention, which is also shown on this slide. So you can see from the figure that we almost reached that minimal detectable change threshold, as denoted by the drop in the STG, which was the strength training group. And the bar that you can see dropping through there is actually the 95% confidence interval for the change. So we weren't too far off being sure that there was actually something going on with the strength training group compared to the control group, but we couldn't say it for sure because we didn't quite get a statistically significant effect. So sorry to bore you with a bit of stats there. With the maximal 20-meter sprint speed, we were much more certain. So we had a statistically significant result as denoted by P less than 0.01. And also the reliability of the 20-meter sprint is a little bit better than running economy. So therefore, we got quite a big change in relation to the minimal detectable change at 95% confidence. So we were pretty sure that as a result of doing strength training, the adolescent distance runners had improved their sprint speed, which particularly for a middle distance runner is obviously very important. I'm just going to move now on to talk about where we fit strength and conditioning into the training week, which is often a question that I get from a lot of runners and coaches. I guess the standard way to fit strength and conditioning into the program is to isolate it as a kind of individual session. And as we did in that intervention, roughly 45 minutes to an hour long, and to make sure that it's separated away from running sessions, particularly key running sessions within the week, as much as possible. So in this example here, you can see the strength training sessions performed on a Monday and a Wednesday afternoon or evening, at least 6 hours from easy aerobic sessions earlier in the day, and about 24 hours from the key sessions of the week, so the interval session on the Tuesday and the tempo running on the Thursday evening. And this seems to work quite well for the majority of runners that can accommodate strength and conditioning in this sort of way. I guess a slightly more controversial approach that I've used with a handful of elite runners over the years, I know it's something that it's employed a little bit within British athletics as well, is placing strength and conditioning on the same day as the hardest running sessions, whereby you can see in the green boxes here, we have a hard interval training session on a Tuesday and a Saturday morning, which might take place at, I don't know, about 10 o'clock. The athlete then has a short break, refuels, probably takes on board some foods that are quite high in protein, and then they go to the gym almost straight away. So they have just an hour or two recovery, and they do their hard strength training sessions of the week around about lunchtime after the hard running sessions. So it seems like quite a controversial suggestion, because in many ways you're obviously going to be heavily fatigued as a result of doing the intensive running sessions earlier in the day. But the rationale for this type of approach, and the reason why some elite runners will prefer it, is it feels like a very polarized design, i.e. we do all of the hard work within the week on individual days, which leaves the kind of Monday, Wednesday and Friday for much more high quality rest and recovery. So the Wednesday just being a kind of easy jog for an hour or so, Friday being a complete rest, and Monday also being a relatively easy day. So we're putting all of the intense sessions on the same day. If we actually have a look at the research and what the research suggests, and whether there's any kind of evidence for this type of approach, if we look at heavy resistance training, so particularly maximal strength type outcomes, you can probably just about get away with this type of approach, particularly with elite runners, if we're training heavy strength. The reason being that if we're lifting a heavy weight, we're obviously not constrained by time. We're not trying to necessarily accelerate it within a given time frame. So if the weight ends up moving very slowly and we're kind of grinding through the session, it doesn't matter too much. It's not necessarily going to blunt the type of adaptive response that we get to heavy resistance training. However, what we do know from the literature is that fatigue from hard running sessions negatively impacts explosive strength development. It's much more sensitive. So if we're trying to train rate of force development, maybe maximal speed, particularly plyometric type qualities, including those types of strength training activities on the same day as interval running sessions, is probably not going to be a great idea. We're not going to get the biggest effect that we could. There's also, I guess, a bit more anecdotally, a bit of a concern for me about performing moderate to high intensity plyometrics so soon after a very hard running session. So we perhaps need to be a bit more thoughtful about where we're putting that type of training within the week. I guess the third very pragmatic approach to planning strength training within the weeks is to not treat strength training as sessions and have 2 or 3 of them spread through the week, but treat it as training units. So on the previous slide where I showed you an individual session, we had movement preparation, we had resistance training, we had plyometric and speed work, and we had some tissue conditioning. So we can actually split that session up into 4 parts if we wish, and spread all of those parts through the week. So we end up doing some form of strength and conditioning on pretty much every single day of the week. So you can see that shown here on this slide, whereby we might do some plyometrics and resistance training some days, some basic movement skill work on other days, and then other tissue specific tissue conditioning work on other days of the week. So I've used this quite successfully with recreational runners in particular, and proposed it in a couple of book chapters and a paper in the past. A further rationale, particularly for more well-trained runners, around microdosing strength training in this sort of training unit way, is the prospect that we might be able to get a performance enhancement within a subsequent training session if we were to put the strength training as part of the warm-up. So we investigated this as part of a study in national and international junior male distance runners as part of a randomized crossover design. So essentially we had a group of 17 male endurance runners who came to the lab and did 2 different types of warm-ups. One of the warm-ups involved some high intensity plyometric training, just a single set, followed by a 10-minute break, and then they got on the treadmill and ran. In the other condition, the warm-up just involved a placebo exercise where they were just moving against body weight and there wasn't really any intensity behind it at all. We measured running economy both before the warm-up and after the warm-up to try to evaluate the response and to see if there was any change. And interestingly, as a result of doing just that single set of intense plyometric work as part of the warm-up, followed by the 10-minute break, we saw a significant improvement in running economy post-intervention, which you can see shown here on the right-hand side. The grey lines essentially represent the individual response, and you can pretty much see that for every single participant that we had in this study, they improved to some extent, some greater than others, but there was a fairly consistent improvement across every single participant we had involved. Just for the final part of the talk, I'm just going to move on to talk about the use of strength training and the potential to try to offset the risk of injury. So I guess based on everything that I've presented so far in this presentation, you might expect that for runners that include strength training as part of their routine, that their main motivation for including it would be an improvement in running economy and performance. But surprisingly, the biggest reason why runners include strength training as part of their routine is they believe that it lowers their risk of getting injured. So it's worth exploring some of the evidence around whether that motivation and the reason that they're doing it is justified. So I guess to start off with a little bit more generally, the literature that's looked at risk factors or kind of reasons that runners pick up overuse type injuries is very, very mixed. There's a lot of contradictions within the literature. There's no definitive conclusions around like 2 or maybe 3 key things that we can be addressing that consistently show or are able to predict overuse injury. The main one that does seem to emerge that's probably relevant for me as a strength and conditioning practitioner, and particularly running coaches, is that previous injury is often a predictor of future injury. So if I have a lot of Achilles tendon type issues, or if I've had a lot of Achilles tendon type issues in the past, the likelihood that I'm going to get an Achilles tendon injury in the future is very, very high. So therefore, it would make sense to either address the reasons why I'm getting an Achilles tendon problem or perform some specific strengthening exercises for that tissue to hopefully try to offset the risk of getting that injury again in the future. Obviously, what I'm more interested in is whether strength and strength in specific muscle groups is a predictor of overuse injury. And we have got some data on this. So in particular, weakness in the hip abductor, so again, the gluteal muscles. There's a number of prospective studies that have shown that's related to knee pain, Achilles tendonitis, shin splints, IT band syndrome, and so on. Weakness in the hip external rotators, which again, as a muscle group is the gluteals, seems to be related to patellofemoral pain. And there's one study that's looked at strength of the calf muscles, and that being a predictor of Achilles tendon overuse injury. So, I mean, based on this information, it seems that strengthening these muscle groups might offset the risk of injury. But as we know in research and academia, these type of correlation studies don't necessarily imply causation. So just because we get the gluteal muscle stronger doesn't necessarily mean it's going to reduce our risk of getting injuries in these areas. So one study that we're conducting at the moment is actually a systematic review to try to address this question, that if we try to strengthen these muscle groups that have got a link, or weakness has got a link to overuse injury, does it result in a reduction in injury rates in the group that are performing them? So we've got this in preparation at the moment. It's one of my PhD students that's leading this systematic review. We've actually found 11 studies. I think there's going to be 9 that are going to make it into the final review. And you can see 7 of those studies shown here on this slide. They've got quite mixed methodologies. So there's a variety of different training durations here, and a lot of them are very short, which is obviously a limitation of the work. A lot of the cohorts that have been used in these studies are quite small, which obviously doesn't give us very much confidence in the results necessarily. And I think a lot of the time, particularly strength and conditioning coaches will look at the types of interventions that these studies have used and say, well, it's not really proper strength training. There's some kind of neuromuscular balance work, there's some targeted work for core stability and so on, but it's not sort of the types of strength training that you saw on those videos a few slides ago. So what you can see here on the right-hand side is that there isn't actually any difference between the group that engaged with strength and conditioning and then the injury rates that we see in a control group that just carry on their normal running. So the evidence isn't convincing at all that performing strength training is going to lower injury risk. I mentioned before that there was just 7 studies on that slide, and we've got at least 9 that are going to go into our final review. So there are a couple that have noted some quite interesting findings. And these are both shown here on this slide. So on the right-hand side, this study took a group of elite orienteers, and they used some neuromuscular exercises, including some strength training, and showed that those that engaged with the program had a significantly lower injury incidence compared to the running-only control group. Similarly, on the right-hand side, a study that lasted a whole year and included barefoot conditioning against a placebo intervention. And part of this barefoot conditioning was supervised as well, which is obviously the strength of the study. And they showed a significant difference in the injury rates between the barefoot conditioning group and the running-only control group, of the order of about 2.4 times less injuries in the intervention group. The main characteristic that I just wanted to point out, which is different to the other 7 studies and might explain why these 2 studies have found something in terms of an effective response from strength and conditioning, is that they used a slightly higher frequency. So they were operating at 4 sessions or 4 training units per week in the intervention group, compared to the other studies, which have typically used 1, 2, or 3. So there might be something in this in terms of the way in which we're organizing strength training or strength and conditioning into the training week with runners, and how frequently we're asking runners to perform it. So there might be a bit of a rationale for actually microdosing strength and conditioning as part of the program. But there's also a bit of a theoretical basis for this, as we know that the cellular signaling which is associated with the adaptations to passive structures, so bone, ligament, and tendon, is maximized with very high intensity brief bouts of exercise. So if we do 2 strength and conditioning sessions a week, which last an hour, that might be great for muscular strength. It might be great for some other neuromuscular type adaptations, but it's not necessarily going to be optimal if we're trying to get changes in passive tissues. So it probably doesn't make any difference if we just do 2 sessions a week, but it would make a difference if we do 5 to 10 minutes of quite high intensity work on every single day of the week. In terms of just gains in strength, we know that if we equate volume between different frequencies of work, it actually makes no difference in the magnitude of gain that we get in maximal strength improvement. And it is worth us looking at literature from other areas, that there's been quite a lot of studies that have used strength and conditioning, neuromuscular type training to try to offset the risk of acute and overuse injuries in other sports and other populations. So in particular, youth soccer, we know that the optimal frequency for doing strength and conditioning work, and this is based on about 20 or so studies, is at least 5 times a week for a duration that's quite short, so 10 to 15 minutes. So for a youth football player, that's actually quite tidy, because it fits quite nicely as part of a warm-up before a football practice, or as part of a broader metabolic conditioning type session. But this is completely uninvestigated in endurance runners, and specifically with overuse injuries. So there's a big gap in the research there for investigating the efficacy of this type of training with runners. If the microdosing of the daily routine of strength and conditioning is worth doing, and if it is effective, it could look a little bit something like this. So this is just to finish off with a video of a home-based strength and conditioning routine with minimal equipment that could be performed in order to gain strength around some key muscle groups and tissues. So we've got the dead leg step up, which if you've got stairs in your house, is fairly easy to perform, and then progress across different heights of chairs. We've got multi-directional hopping exercises. The athlete in this video has actually got their trainers on, and they should probably have their trainers off for that. Got variations of bridging exercises, single leg glute bridge being a reasonable start point for most runners. We've got specific strengthening for the gluteal muscles, so something like a sideline leg raise. And the athlete here has obviously got a resistance band on, which is challenging them further. Different variations of planking exercises, so the side plank being a good one. And then I would generally always include at least one exercise for the calf complex, so something like a single leg calf raise, which can obviously be progressed again quite easily. So yeah, I think that's about 45 minutes or so, and I'm happy to take questions after a quick summary here. So we know that strength training added to the program of endurance runners of most abilities, both sexes, seems to improve running economy and anaerobic qualities, which translates to improvements in performance. And we don't tend to see much change in muscle mass, at least over a period of a few months. We're a little bit less certain with postpubertal adolescent distance runners based on the study that I presented to you. But there's probably other reasons that we want to be engaging youth runners in strength training as well. For performance improvements, again, improvements in running economy and time trial performance, we should be getting runners to engage with strength training a couple of times a week. And those sessions can either just be resistance training or a combination of resistance training, plyometrics, and some specific tissue conditioning work. We're much more uncertain around the role that strength training plays in reducing the risk of overuse injury in distance runners. However, we have got some evidence that muscular weakness, particularly around the hip, is related to overuse injuries. And I've kind of speculated, again, there's not much research on this at the moment in runners, but I've speculated towards the end that the microdosing or the high frequency approach to incorporating strength and conditioning into the routine of runners might be the most efficacious approach to reducing injury risk. Many thanks for giving up, best part of an hour of your evening to listen to me. I was going to include a slide on a couple of studies that we're recruiting for at the moment, but I haven't included it. But if anybody is interested in getting involved with research at Loughborough University, we've got 2 studies which are going to be starting in the next month. One intervention study looking at a heavy resistance training intervention, and one study more looking at injury rates and long-term monitoring of bone health over a long period of time. So if you want to get involved with those, particularly if you're fairly local to Loughborough, please send me an email or send me a message on Twitter, and I'll be happy to have a chat. Thanks very much.
Thanks very much, Rich. That was really, really interesting. Thank you everyone for joining us. So my name is Esther and I'm just going to help out with the Q&A a little bit. So if anybody does have any questions that you'd like to ask Rich, please could you raise your hand. The raise hand option is under reactions at the bottom of the screen, and then we will get to as many of them as we can. Rich mentioned recruitment for studies there as well. If you are interested in taking part in any of his studies, you can email the NCSEM inbox as well, and we will join you up with Rich. So at the moment, don't think we've got anybody raised. Oh, hang on, I speak too soon. Jonathan Moore, would you like to unmute and ask your question?
Great, thanks very much. And thank you very much for the presentation, really, really helpful. On one of your slides, you talked about the gap between doing strength work and when you do your running sessions. And sort of obviously, as sort of non-professional runners, a lot of us have constraints on our time. And you know, what I've been typically doing with the strength work at the gym has been do my easy recovery run for an hour or something like that, and then sort of head straight to the gym to do the strength work in the morning because the evenings don't work. Is that pretty suboptimal? Is there still decent benefits from doing it that way? Or should I trying to think of more alternatives to fitting that into my schedule?
Yeah, hi Jonathan, and thanks very much for your question. Yeah, I completely appreciate that, particularly recreational runners and runners that have got very busy lifestyles, jobs, families, etc. Like trying to incorporate strength training into the week when you're understandably not willing to sacrifice any running sessions is often very difficult. I think the way that you're doing it at the moment is definitely better than nothing. Like you'll definitely be improving neuromuscular characteristics, which are likely to improve your running economy and time trial performance. So I would keep doing it for sure. It's probably not optimal, but yeah, we've got to kind of work within the constraints that we've got in our own lifestyle. So I think you're better off doing that than trying to find like an extra hour or 45 minutes in the evening to get in the car, go to a gym or whatever. It's just not practical. And I think a lot of the time when coaches sort of force runners to do things like that, they end up getting demotivated because they can't find the time to accommodate it. And they just want to stick to their running, which is completely understandable. I I mean, the only other option, and I sort of presented this on the microdosing slide, is to include very short periods of strength training, maybe in the evening. As I say, I kind of heavily speculate that might help injury risk reduction, like a high frequency approach, but it might also be a way just to fit it into your overall week. If you've got any equipment at home and you can do a sort of quick 15-20 minutes in the evening, like for things like plyometrics, you don't actually need any kit because it's just jumping on the spot or find a quiet road somewhere and do a little bit of hopping. And so you can do things like that in the evening if time allows.
Great. If I could sneak in a second one,
Yeah, sure.
sort of in terms of marathon training, if I should get into that last 3-4 weeks of marathon training, you're thinking about tapering on the running side, what should you be thinking about doing on the strength side as well, please?
Yeah, it's a great question. So I'd follow the same rules with strength training as you do with running. So the taper is a little bit individual, and the research kind of supports that. So I think if you've done a few half marathons or marathons, you've probably found a bit of a taper pattern that works best for you. But typically I would start about 2 weeks before. I'd have a bit of an exponential drop in volume. So what I mean by that is you start to reduce volume quite quickly, 2 weeks out from before the main event, and you drop the volume by around about 50% in total. So to bring it to life, for example, if you go to the gym and you do 12 sets of strength type work, like you would bring that down to initially about 8 sets and then probably down to about 6 sets of work. Keep the intensity about the same, and if anything, slightly increase it. So don't necessarily just start lifting very, very light because you're worried about, I don't know, fatigue. Like try to keep the intensity the same and try to keep the frequency of the same as well, because physiologically we seem to respond best to kind of routine. And if you suddenly start dropping physical training sessions out, like you probably feel a bit fresher initially, but usually you don't perform quite as well on the day. I think obviously because strength training's a very general training activity, it's nowhere near as important as your actual running. If you want to drop it completely in the last sort of week or two, there's nothing wrong with that. Like you're not going to lose neuromuscular adaptations that quickly. And so I have had runners that are like, I'm not doing any strength work, Rich, in the last week. And I'm obviously like, well, that's completely fine. But if they want to keep it going because they want to stay within their routine, that's what I'd be doing. I'll be dropping the volume by about 50%, keeping the intensity the same.
Fantastic. Thank you very much.
Okay.
Thanks very much, Jonathan. Really, really interesting questions. Dom Shepherd, I think, has also got your hand up if you'd like to unmute and ask your question.
Lovely. Thanks, Rich. Great presentation. My question is around hill training as a method in of itself to improve strength and get that running benefit in. So improving your anaerobic threshold, but also hitting the key muscle groups. So not missing out on the running, but still getting some strength training benefits, and whether there's a lot of benefit to doing that as a strength training session.
Yeah, and I think there is quite a lot of coaches that will call like running up hills a sort of form of strength training. I think if you just compare them, first of all, so if you take, I don't know what the steepest hill is in the UK, it's like 34% or something. Like typically the sorts of hills that people pick to do hard efforts up, something between about 10 and 15%. If you compare that to doing like a box step up like you saw on the video, like a box step up, if you transition forward by 30 centimeters and you go up by 30 centimeters, it's an incline of 100%. And so the stimulus that you're giving to your neuromuscular system, like a single step up a hill compared to a single step with a heavy weight on a box, like for me anyway, isn't comparable. Like you'll get a very small neuromuscular stimulus by running up a hill. You'll get a very large neuromuscular stimulus by stepping onto a box, which is why you can only do 6 repetitions of a step up. But you'll maybe do, I don't know, if you sprint up a hill for 100 meters and it takes you 15 seconds, let's say, like there's going to be at least 45 foot contacts or repetitions in there. So it's over 20 at an absolute minimum per leg. And so I don't think the stimulus to the neuromuscular system is that comparable. I think actually the benefit, if you do get a strength benefit to hill sprinting, it's probably on the downhill because there's a really large eccentric component. And so if you do anything more than a jog going down a very steep hill, like that's probably quite a big stimulus to your neuromuscular system, and of course soreness as well. Whereas I think running up a hill, like I'm definitely not saying that hill running isn't a good modality of training. Like I think it's obviously something that all runners should be doing, but I'd be having it as part of running sessions and thinking about strength training as something very different, like a much bigger stimulus to the neuromuscular system. So hopefully that kind of answers your question, that both are important. And I don't think we can kind of discuss them as being the same thing.
Brilliant. Thanks, Rich. Thank you.
Thanks, Dom.
That's great. Thanks very much, Dom. Yeah, if anyone else has a question, please do feel free to raise your hand. I have had one come through separately that I'm not sure if it's your area exactly, Rich, but I will ask it. So do you have information on pelvic floor dysfunction? This is a factor preventing 1 in 3 postpartum females returning to running, and heavy strength training exercise would compromise the pelvic floor even more if not treated. So do you have research on that, and is it if it's dysfunctional, will it have a significant effect on participation and performance?
Yeah, it's thanks for preempting my response there a little bit. It's certainly not my area of research, and I'm pretty sure there will be quite a decent body of research on that, specifically with runners, and specifically runners that are wanting to return back to performance, probably less so, or maybe non-existent. I mean, I guess with my coach's hat on, and yeah, sort of forgetting about the pure research side of things for a minute. I mean, if I was coaching the person that asked that question, we wouldn't be doing any, well, particularly heavy strength work initially. Like we might be doing some basic movement skill, body weight type exercises, particularly exercises that are based on the floor. But most of the training would be heavily geared around like pelvic floor type work, working other muscles around the core, such as transverse abdominis and multifidus and so on. Eventually moving on to trying to encourage a bit more bracing around that area. And trying to use as many of the muscle groups around the trunk as possible to stabilize and strengthen the spine. And at that point, then you can start potentially looking at moving on to resistance machines and yeah, multi-joint type exercises. But heavy strength work would certainly be quite a long way down the road for an individual like that.
Fantastic, thank you. I think you've answered that quite well. One from me, actually. What are the practical things people can do at home if you've got limits? Some of the stuff that you were showing is obviously in a gym with quite a lot of equipment. If people are at home, have got children or whatever, can't go out in the evenings so much, what can you do at home with equipment that you might already have or that's quite low cost to purchase?
Yeah, it's a really good practical question, and I'm certainly not standing here selling gym memberships to Powerbase on campus or anything. So yeah, the final video that I showed in the presentation had some useful exercises. I think the only piece of equipment that was in that was a resistance band. And so there's definitely quite a long way you can go just with body weight, because if you take an exercise like a single leg squat, so if I was to stand on the ground just on one leg, and I was to squat all the way to the ground, so touch my bum all the way down to my heel and then stand back up, like that's an incredibly hard exercise. Even for somebody that's very, very strong, that's a hard exercise. So if you think about that as being, I guess, something that's quite advanced that you need a lot of strength for, there's obviously more simple versions of single leg squatting and stepping and lunging patterns, which can offer quite a decent neuromuscular strength stimulus. So I would start with some of those, and you can do those in the comfort of your own home. So split squats, rear foot elevated split squats, dead leg step ups, and even improvising with, I guess, any heavy objects that you can find around the home, like filling up a backpack with heavy tin cans and things like this. Getting a young child to sit on your back.
To sit still on your back.
Yes, sit still on your back. I mean, the other exercise which every runner that I've worked with has had in their program is single leg calf raises. And I didn't touch upon it in the presentation, but we know the soleus in particular, which is the muscle deep within the calf complex, is the biggest energy consumer that we've got in the lower limb as part of running. And so when I defined running economy right at the start of the presentation, and we know that running economy can be affected by strength training. Like probably the best muscle to target, if we're going to talk about muscles, is the soleus. So I would have every runner doing some form of calf work and probably some bent leg calf exercises. And you can do those in the comfort of your own home for sure.
Fantastic. Thank you. You've given me some good ideas. We've got a couple of other people with their hands up. So we'll go to Ian Martin first, if you'd like to unmute.
Oh, thanks. I really enjoyed the presentation. Some really useful videos in there that I thought were excellent. So hopefully, if we do get a recording, there'll be kind of a good resource there for technique on various things. Just one question really for consideration for programming these exercises as a circuit. So over winter, we generally move indoors into the sports hall and we do some circuit training. Just wondering whether, kind of we should focus on, certain exercises in a circuit, whether we should be, we kind of do an Oregon circuit where we run around and then, stop and then do an exercise and then run again, whether that's a good way of doing it. Just your thoughts really, Rich, on programming circuits. Yeah,
I think organizing exercises like in a circuit, particularly if you've got very large groups of runners, is a really good idea. I guess what I tend to stay away from, and it does depend on the group of runners that you're working with to some extent, but if the circuit's sort of very traditional, that kind of military type circuit where it's very metabolic, like you're pouring with sweat, you're breathing really hard, it's quite anaerobic in nature. And so in other words, you've got very intense exercise with very short recoveries and you're just bouncing from exercise to exercise. Like I typically don't use those very much, mainly because like runners get a lot of metabolic and cardiovascular stimulus from their running training. And so they'll already be getting that maybe 3, 4, 5, 6 times a week, particularly with the hard interval running session. So if I give them more of it and it's very general, non-running type exercises, I can't really see a sort of a strong rationale for doing that. Whereas if the exercises are arranged as a circuit, there's a priority on movement quality. There's a priority on like intensity of exercise, but then having a decent enough recovery so that you can then perform at the same intensity on the next exercise. I think that's completely fine. And I mean, I used to run a strength and conditioning class with runners at my previous institution, and we used to get anything from sort of 10 to 25 show up. And arranging the exercises in a circuit for some parts of the session was the only way you could do it. Like otherwise you'd have been there 3 hours. And so I've used kind of, if you want to call it circuit training, but there's always a priority on, trying to activate the right muscle groups, like making sure the movement's correct, and then just having enough recovery before you go on to the next exercise so it doesn't decrease the intensity on the next bout of work. Hopefully that helps.
Yeah, thank you. I mean, just a short follow-up, if I may. One of the problems I have as a coach is that with endurance runners, a lot of them want to, be out of breath, and they want to kind of beast themselves in a circuit. So it's quite difficult with kind of non-elite runners to get them to understand that actually slowing down and taking the time over the exercises will be more beneficial. I don't know if you've got any tips for kind of, persuading them the best way to do it.
Yeah, 100%. I completely relate to that, because I mean, with all the runners that I've worked with over the last 15 years, like it says 3 minutes rest on the program, but they're happy to take a minute, and they probably don't need 3 minutes because of the type of athlete they are. They do recover very, very quickly between sets of work. I mean, you could organize exercises in a way that just makes sure that you're working at, I guess, different muscle groups and movement patterns, and so it doesn't necessitate quite as much rest, I guess. So it's like an upper body, lower body, or upper core stability and then lower body. So you can reduce the rest a little bit in that regard. I mean, I said right at the start of my first response to your question, it depends a bit on the group of runners. And you sort of hit the nail on the head where you said, okay, I'm working with a group of recreational runners. And if most of them are only running, I don't know, 2, 3, 4 times a week, maybe, like having another metabolic stimulus in the program. So to some extent, disregarding my presentation and thinking about it as a metabolic conditioning session might not necessarily be a bad thing. particularly if some of them only run easy all week. If all they do is just run easy or steady, and you think, okay, they get a really big metabolic stress from coming and doing circuit training with me, then that would be a reason to have it as more of a kind of metabolic type session, if that makes sense. So I think that's when it does depend. But if they're doing 2 very hard interval sessions a week, yeah, I'd be a little bit more cautious about adding another one with just general exercises.
Great, thank you.
Thanks, Ian.
Thank you very much, Ian. And we are recording this, and you will get an email letting you know when the recording is available, hopefully later in the week. So we've got 3 people with their hands up. So we will go to those 3 people, and then I think we will need to wrap this up. So first of all, I'll go to Chris Kitson for the next question, please, Chris.
I know 2 of them that have got their hands up out of these 3.
Is there anyone I need to blacklist and not?
No, it's fine.
Thank you very much. Thank you, Rich, as well.
Hi, Chris.
Thank you. So yeah, it was just probably fairly basic, to be honest, but just with regards to kind of minimal effective dosage of volume, and on the kind of flip side of that, if there's a kind of upper end of that where we start to see kind of detriment in performance, or if it's just a case of just monitoring the athlete's performance, basically, from that.
Yeah, thanks for that question, Chris. There has been one study that showed improvements in running economy and time trial, I think, with just 1 session a week. It was a plyometric study. And so obviously plyometrics is that little bit more specific. It's quite intense in nature. So that probably explains why they got an improvement just with 1 individual session a week. There has been sort of detraining studies that have shown that if you use 1 session a week after an intervention, it maintains quite nicely, both in terms of strength and in terms of improvements in running economy. So I typically wouldn't advise just doing 1. I think 1's quite a nice maintenance type dose, particularly for athletes that have got long in-season periods like middle distance track runners. But 2 sort of defined sessions per week in the way that I've presented seems to be optimal in terms of a kind of minimal dose response. And then in terms of an upper limit, I don't think that's ever been investigated. I'd say it'd be detrimental when you start dropping so much running from your program that you're not improving because you're not doing enough running. Like as I alluded to before, the most important thing for runners is obviously to run. And so that side of their training has to be optimal. And the strength and conditioning is just there as a bit of a supplement. And so if you do go to 3 or 4 sessions a week, I guess there's a risk that they might gain muscle mass, but there's definitely a risk that you're going to start impacting your running training, either because you're dropping it out or because you're just so fatigued you can't run properly.
Yeah, fantastic. Brilliant. Thank you very much.
Cheers, Chris.
Thanks very much, Chris. And Jane Clark, would you like to ask your question?
Hi, Richard. Feared
Hi,
I was going to get blackballed then. Fantastic as always.
Thank you.
It kind of leads on a little bit from Jonathan's question and people that have very little time.
Yeah.
When you were organising your week and slotting various strength and conditioning sessions in, they seem to be afternoon or evening. Would that mean that you think early mornings are a real no-go?
Not at all, no. I mean, again, from a very practical perspective, I would usually just work with the runner and what time they've got available. So what their lifestyle commitments are, their working patterns and so on, if they've got any preferences around when they'd prefer to strength train. I mean, if we look at the sort of circadian rhythm research, like we know that physical performance for most of us is better in the kind of late afternoon, early evening. So, I mean, it's usually when I try to do my hard interval training and strength training because I don't really feel up to it in the morning. So there is a bit of an individual preference there. But there's lots of runners and quite a few studies that have, I think, used morning training sessions. So there's definitely no disadvantage to doing it in the morning versus the evening. It's just where you can fit it in, basically.
That's great. Thanks very much for that question, Jane. And then last but by no means least, Ewan.
Oh. Hi, can you hear me?
Yes, we
Yeah,
can
hi,
hear you.
how are
We
you?
love your
Hi there, how
question.
are you?
Thanks.
Yeah, sorry, my question is on isometric exercise. I work with young athletes, generally from 14 to 17. We've been doing compound and Olympic variations, back squats, etc. pretty successfully. Do you think I should be giving more of an emphasis to isometric exercises with the younger group with regards to tissue development? And if so, what sort of prescription with regards progressively overloading do you think I should increase duration or increase intensity in the blocks?
Yeah, it's again another really good question. I mean, typically with younger athletes, as much as we want to try and improve their sports performance and economy and so on, like I'd always want to try to just be improving like movement literacy. And so I'd tend to use a broader range of exercises over a long period of time with younger runners, maybe compared to senior middle and long distance runners. And yeah, when we say movement literacy, like I want to get all young athletes in particular working through range and working with high levels of skill and control across a lot of different exercises. So I probably, it's not to say you wouldn't use isometrics with kids, but I'd probably stick more with what you've been doing in terms of the sort of typical eccentric, concentric, like developing range of movement and skill with the younger athletes. There's definitely a place for isometrics, particularly in terms of tendon development. So we seem to get like larger increases in collagen synthesis with isometrics. So like I use quite a lot of isometrics with runners around the Achilles tendon complex. But again, to do that, you need either a Smith machine or a leg press. Like you need the kit and equipment to be able to get enough load through the joint that it's giving the stimulus. So if you haven't got that, if it's a kind of athletics club setting or you're having to do it at home, it's a little bit more tricky. So you've either got to improvise with kind of door frames and or objects around the house, or just stick with sort of more traditional training. And so I think for some injury prevention work, particularly around the calf complex, isometrics are particularly useful. Again, hamstrings. Like I've used quite a lot of isometrics before. So various different bridge holds seem to be good for like high hamstring tendons. But yeah, like throwing a little bit of isometric work in isn't going to do any harm. But I think based on what, like the brief part that you said at the start around what you're already doing, that seems to me to be more effective, and I'd carry on prioritizing that.
That's grand, thanks.
Cheers, Ewan.
Fantastic. Thank you very much. I think we will draw this to a close as we've run over a little bit already, but we've had some really, really good questions. So I did want to give as many people as possible the opportunity to ask one. So yeah, it just remains to say thank you very much to Rich for this evening's talk, and thank you to everybody that has asked a question. It's been really, really, really good debate at the end, and I've certainly learnt an awful lot as well. As I said previously, we have recorded the session and we will make that available online, hopefully later this week, and you will all get an email letting you know when it's available. So thank you very much, Rich. And yeah, hopefully we will see you all for another public lecture again sometime soon. Thank you.
Thanks, everybody.